All right, so I'm not going to prove this, but this differential equation, which is called the logistic differential equation, talks about the P, the population, T, the time, K is a constant, and M is called the carrying capacity. So this is the rate. You remember, derivative is a rate. This is the rate the population is growing. So the population is growing, and we're talking about bears on an island, fish in a lake. There is some capacity. We're going to call that M. That's the carrying capacity. So there's no more than that will grow. All right. P sub 0 is called the initial population, and then we'll have this A that we'll have to figure out, which is the carrying capacity minus this initial population divided by the initial population. All right, so what I'm not going to prove is that solution to this differential equation is this. So the capital M here, and then the A that I have to go find, and little k, which comes from this number right here. All right, so here is your typical question. So first off, I have a lake stocked with 400 fish. So that tells me P naught is 400. And I know the carrying capacity is 10,000. So at capital M is equal to 10,000. So I've got the information I need to solve for my A. 10,000 minus 400 over 400 gives me A is 24. So I'm putting together my equation here. So I have 10,000, 1 plus 24 e to the negative kt. All right, so they give you information to solve for the e to the negative k. This is very similar to what we did way back in Newton's law of cooling. So t is 2 years, the population is 1,000. 2 years, the population is 1,000. So we're using that, and we're going to solve for e to the negative k. So here it is with 1,000, and I put in the t is 2 years. So a cross multiply. Divide 10,000 by 1,000, I got 10 here. So then I'm going to solve for e to the negative k. So subtract 1, so I get 9. Divide by 24, so I get e to the negative 2k is 9 over 24. Do not take the ln. Remember, you're solving for e to the negative k. So that means I'm going to take the 1/2 power of both sides of this. So here it is. So e to the negative k is 9 over 24 to the 1/2 power. So I put that in place of e to the negative k here. So I get 9 over 24 to the 1/2 power, and that's all to the t, so that's t over 2. All right, so there's my equation. So what I want to make sure that you don't do, so see, almost always you'll have this here, where this number will match this number, so you would never cancel the 24s. That would be really bad math, right? So keep it there. So now I'm ready to answer the question. So how long, find the time, how long to get to the population of 5,000? So I'm going to set 5,000 in for the P, and I'm going to solve for the T. So I'm going to cross multiply, put this up, put this down, and then this gives me a 2. Then I'm going to subtract 1 so that I get 1. So I'm left with this. So let's divide through by 24. Now this is a time I must take the ln to get the t over 2 out of the exponent. So I take the ln of both sides. So the t over 2 comes down in the front. So then I multiply by 2, and I divide through by ln of 9 over 24. So that's the amount of time that it takes for the population to grow to 5,000.